Hello and welcome to this part of our computation. We've been looking at mixed numbers and the operation subtraction. So if we have mixed number cases and we have to add or subtract, the rule says that we can only do that when the terms are actually alike. In other sense, for fractions to be alike, we have to do the common denominations and then work from there. It was pretty easy with addition, and we also look at the case where fractions may start introducing some aspects that actually went a little bit against our normal way of thinking. So if we have a case like that, those ambiguities must be addressed appropriately. Otherwise, you might introduce a lot of error in your computation. So this is a case where we want to examine the question, when do we actually have to borrow from the whole? Okay, so we are looking at the conditions that probably would give rise to borrowing if you want to add in the mixed form without having to use the guarantee approach. So let's quickly get through this and see what that would give us. So a couple of things we want to do. We're saying that examine what the portion that we've been referring to as the fraction part, okay, where we have the fractions and not the wholes. So in order to establish that condition, that is exactly what we want to do. Okay, so I have the left top, okay, and then I have the right top. Let's call them so, since we don't want to use too much vocabulary here. Just want to examine the computation in a way that we can work with. So let's say we have something like this. So we are actually saying that picking these two aspects, if I know the left top and the right top, I compare them only to realize that the value on the left is less than the value on the right. What this implies is that if I do the subtraction, left top minus the right top, okay, the result here must be equal to negative number. That's what you get. All right. So if this is the case, then the result is becoming negative. If this is less, then you are getting the result to be negative. Okay. And we earlier on established that the left top minus the right top should not give you a negative answer. And if that is the case, you have to address it. So this is a perfect condition for borrowing. And that is the case. What we want to do is to what? Borrow from the top. Okay? But what are you going to borrow? The condition says what? Borrow from the whole number of the left term. Okay, so the borrowing is taking place from the whole on the left term. If you ask, what are you borrowing? Actually, you're borrowing a value of 1. Okay, and that should be borrowed from the left term. So quickly, what we want to do now is take a look at instances where we can predict the occurrence of a situation arising where we have to borrow ahead of time before we do that. Okay, and the way we want to do this actually is through the use of what? The product rule. Okay, so let me put here how to predict when to borrow. So in attempt to check, what I'm asking you to do is to what? Use what we've been referring to as the product rule. Very important you do that. Okay. All right. So how are we going to use the product rule? We'll say what? Say I'm given the top. I have my left top and I have my right top. Okay. Okay, so we are saying that if we have a situation where this is the case, basically we are saying that if this is the case, then what you need to do is to what? Examine the partial products. Okay. What do I mean by examining the partial products? Don't forget that what? The simple forms usually come like this. Okay. All right. We've seen this many times. And what we want you to do is actually what? Examine this. And then compare the results. Okay. So I will take the next page and just show you quickly what can happen. All right. So far, so good. Yeah, I can hear you. Good job. All right. So what we want to do here is to take a specific case and then process what is happening. Okay. So I'm going to put two separate examples and see how we look at that. So in the first example, what are we looking at? Okay, so in the first example, let's say I'm giving something like 3, 1 over 3 minus 2, 1 over 4. Okay. What we said earlier is that take the fraction part and examine them. So these are my fraction parts. And I want to what? Examine the fraction part. Okay. So let me rewrite that quickly. So I'm going to have 1 over 3 and I'm going to have 1 over 4. Now what I want to do here is that I want to examine the right top and the left top. So let me call this the right top. I'll go like this. So which means what? 3 went and multiply 1 and the result is what? 3. Then the next thing I want to do is to examine the left top. Which will be this. Which means what? 4 goes to multiply my 1 and I have 4. Okay. So what do I do from here? Compare. So now compare what? Partial products. Okay, which will be this and this. So what am I looking at? Here I have 4. And here I have what? 3. The question is, which number is bigger? 4 is bigger So in other sense, 4 is greater than 3. Whenever we find a situation like that, what can we say? We say this is what? Perfect form. And in this perfect form, we said what? No borrowing is required. Okay? So when you get a perfect form like this, no borrowing is required. That means that the given fractions are good to go. So move on with your computation. Okay? So you're okay with the given fractions. Basically, that is what we're saying. The given mixed forms are good to go. All right? So we're saying that the given mixed forms are good to go. Let's look at another case where we are given something like 4, 1 over 6 minus 2, 5 over 6. Not bad looking. Again, these are my fraction parts. What do I want to do with the fraction parts? I want to what? Examine the fraction part. Okay, so let me rewrite that for simplicity. 5 over 6. Can I find my left top? My left top, I'm going this way, which is what? 6 multiplying 1. The result is what? 6. Can I find my right top? Go this way. 6 multiply 5, and that gives me what? Is it 30? Okay, so we got 30. What do I do from here? I want to what? Compare the partial product. So let me put a note here. Now what we want to do, now I want to compare my partial product. And what are my partial products? I have 6 on the left, and I have what? 30 on the right. And if I compare 30 and 6, it's obvious that what? 30 is greater, okay, than 6. So the mouth of the inequality will swallow that. Yeah, that is one way to get it. Okay, this part, the tail part is very small, so the small number goes there, just in case you're having a problem with how we use the inequality signs. That is just a way to get it. If it's on a number line, it's a different thing. If it's hanging in there without any numbers, but if you start putting numbers together, it depends on how you're saying it. 30 is greater than 6, or 6 is less than 30. Okay, so enough of that. What we're really looking at is which number is greater. 30 is greater than that. Okay, so we've examined that. The condition, we are saying that when the left top is smaller than the right top, then we have a recipe for borrowing. Okay, so let's make that note here before we get into computation. So here we can say that what? Borrowing condition exists. Okay, so with this, in here we said this is a perfect case you can go. In here we say what? There is a need to borrow. Can we say a little more than that? Absolutely. So let's say here, therefore, what we want to do is to what? Borrow 1 from the left whole. Okay, therefore you have to borrow 1 from the left whole. And that means what? We would have to what? And the left whole is what? The number 4. Don't forget that. So that would take me all the way to the top. Okay. That's what we are referring to. So anytime you see conditions like that, we say what? You want to what? Borrow actually 1 from that 4. So in the next video, we will be examining how that actually takes place. And then we justify the condition. Okay, so quickly, let me get into that since we've spent a lot longer than we anticipated. Okay. So on this page, what I want to do is to justify the concept of borrowing from the whole number using the appropriate rules. Okay. And I want to consider 5 1 over 6 minus 2 4 over 6. Hopefully, I would get this in a manner that you can follow. And if you have any questions, feel free and continue to send it in. Okay. Like we said, we want to examine the logic of things. So thanks for hanging in. So let's see. Step 1. Step number 1 says what? Check on the fraction part using the appropriate rules. Okay. So check on the fraction part. That's the way we approach this. Okay. And in step 2, we will do the rewrite. What I want to do here is to what? Rewrite. Okay, so take note how we go about the 2 steps. All right. So what are my fractions that I'll be looking at? I'll be looking at what? 1 over 6, and then what? 4 over 6. So I have 1 over 6, and I have 4 over 6. And we said that what? 2 things can happen. If I want the left top, how do I get that? Go this way. So basically 6 goes to multiply 1. The result is 6. And if I want to get what? The right top, 6 should go multiply 4. 6 multiply 4. The result is what? 24. So what do I do? If I compare 6 and 24, we are saying that what? 24 is greater. So the condition says what? Borrow from the whole number on the left. Therefore, borrow from left. Okay? So from step 1, we've been able to identify that there is a need to borrow because we have prepped that. Okay? Now, let's see how that is done in the step 2. So from the left whole, borrow from the left whole. Okay? And the left whole in this case, as we are given, is 5. So let me also make that note here. Okay, so you see exactly why we're doing this. All right, so what I want to do actually is to isolate this part. If you can still see from that far, I isolate this 5 whole number, 1 over 6, and process that. Okay, I hope that would help a little bit. So I'm just going to take this part and quickly bring it right in here and work with that. So what do I have? 5, 1 over 6. Well, earlier on we said by definition, we can rewrite this as what? 5 plus 1 over 6. Okay? I'm borrowing from the whole number 5. So I have to find another way to rewrite 5 without complicating the whole process. 5, I can rewrite as what? 4 plus 1. Okay, I'm not interested in using minus because we just make the things more complex. So this is one form which I probably can process easily. All right, so 4 plus 1 gives me 5, and 5 plus 1 over 6 will be the same as 5 whole number 1 over 6. Okay, so just by definition we are moving on this case. All right, so what this is telling me is that I can do better than that. And how do I do that? I can rewrite this now as 4 plus 1 plus 1 over 6. Well, so what I want to actually process is 4 plus 1 plus 1 over 6. But my focus actually is working the 1 plus 1 over 6. Two things actually we can do. In one sense, we can say, okay, by the rule of special 1, we can rewrite this one as what? 6 over 6 and process from there. Or we can just say, okay, this is the same as what? 1 whole, 1 over 6. And then to get the improper part, we just do what? The bottom times the whole plus the top. Okay? So let me do that quickly just in case. Just to freshen up some few things we have covered before. Okay? So one way to go about it is, okay, by definition, again, by definition, okay, we can rewrite this as 1 over 6, and therefore this is equal to what? This times this plus this, which will be 7 over 6. 6 times 1, 6 plus 1, 7. 7 over 6. The bottom doesn't change. Okay, we have a video to cover that. Then in this case, I'm looking at 1 plus 1 over 6, and I'm rewriting this as what? 6 over 6 plus 1 over 6. The bottoms are the same, right? 1. The top is the first plus the second. And this will be what? 7 over 6. Okay? So that also gives us the 7 over 6. So there are two basic ways to go about that. Okay? So we know now that by definition, if we process this part, we are getting nothing but what? 7 over 6. What we want to do is to add what? To the 7 over 6, we want to add this 4. So it's 4 plus 7 over 6. And if we compute that correctly, we will get what? 4, 7 over 6. But we just said something interesting happened here. We said what? The top, considering the fraction, the top cannot be bigger than the bottom. But here's a case where we've realized something is happening. We are not stopping here. That is what you have to understand. This is in a transition. Okay? If this is your final answer, then there is a problem. This is in transition. Okay? Because if you process this as a final answer, there will be the fraction part to result into one whole number, 1 over 6, and that one goes to add, giving you back the same thing. Okay? So we haven't actually compromised the integrity of what we're doing. This is in a progress. Let me make that note here. So note that what? It's in progress. It's in progress. So when we get to the next video, hopefully we'll start doing some computations. Rewrite as mixed case. Okay, so when we rewrite this as a mixed case, this is what we are getting. But this is a form that we can work with, because by going back in there, you see that what? The top here is 7. The fraction we had before, we were looking at what? 2, 4 over 6. So this now becomes 4, 1 over 7. And if the bottom are the same, I'm working with the fraction 7 minus 4 will give me a positive. And that position this thing for a perfect work. Okay, I hope this helped to some extent. If there is anything to add to this, what we can probably do here, hope we have enough space to wrap that up. We way past the usual time I was estimating. So we were given something like 5, 1 over 6 minus 2, 4 over 6. What we did is to rewrite in attempt to solve it, we say we'll get what? 4/7/6 minus 2/4/6. So this is the way you want to actually look at that. So this is what we'll be doing in our next step. This is what you want to solve. Okay, and don't forget what we did here. Okay, this is our rewrite. All right. I hope this discussion helped. Like we're saying, we take time to examine the logic of things because in our next step, we want to have the confidence to do the things we want to do without leaving any place for error or compromising the integrity of what the computation required of us. I hope this video helped you. We are about 25 minutes into it. And let me hear your feedback, okay? And if I helped you in this journey, then I've done my part, okay? Keep it up and keep studying.